Hello, we're Group D5, and our project is Virtual Reality Bicycle Therapy. We're Yusuf Salman, Stephanie Cordoba, Yair Pineda, Ana Saruji, Brendan Warren, and Ihsan.
During the fall semester, we worked towards completion of a 3D CAD design for a pedal to be utilized in physical therapy. After considering the criteria that it must be lightweight, durable, and capable of encasing the electronic components, we were able to achieve our first printed prototype made of plastic. After purchasing and collecting the required components, moving forward, we would ideally incorporate the electronics and conduct testing of the pedal in order to analyze appropriate feedback responses. We have the components to achieve a sensor system within the pedal, which will communicate wirelessly with a MATLAB system. The programming will allow us to analyze and read the data collected from an Arduino board in the pedal as someone bikes. This would essentially lead to print the final product utilizing a better material such as Mark-forged onyx. Overall, we wish to complete coding within MATLAB in order to read the data collected and to set up the electronics appropriately for testing.
Patients may often suffer from chronic leg, knee, or hip injuries that lead to imbalance in their movement. Cycling therapy can often help patients strengthen lower body muscles and improve balance. Because VR is a new and upcoming piece of technology, we wanted to integrate it with the experience to help patients receive treatment. Stationing a bicycle in front of a monitor displaying a VR software helps immerse the patient and allows them to rehabilitate in a controlled environment. For our design project, we sought to create a detachable bicycle pedal integrated with various sensors that could wirelessly connect to an interface developed in MATLAB. I can indicate where the patient is applying too much pressure, how fast they're moving, and how to maintain balance.
The main design principle we have chosen is efficiency. We prioritized and focused on packaging, ease of construction, while aiming not to compromise the strength requirements of the design. We sought a small, simple, robust design for our pedal that can ideally be attached to an ordinary bicycle. We chose to use the standard dimensions used on the axles designed for ordinary bicycles in order to make our pedal universally compatible and to ease the setup and testing of our prototype during the troubleshooting and construction process. To begin the design process, we had to obtain measurements of the sensors and components chosen to house and mount them in an elegant and effective manner. For the next step, we created a 3D CAD model of the modular components using SolidWorks to be sent in for additive manufacturing. Other component designs included a metal plate to be machined and placed on top of the load cell to prevent breaking when the user's weight is applied onto it, Velcro straps around the user's feet and to secure them in place, springs to allow the upward and downward motion of feet to be accounted for by the software.
3D printing was chosen as the easiest and most cost-effective way to craft the body of the pedal while still maintaining the structural components necessary to hold our electronics. A metal force plate was chosen to provide the most strength and resilience with minimal size and weight. For our electronics, the specific load cell and op amp we used were chosen for their specialization in the use of force measurements and could be easily tied to a microcontroller. For our microcontroller, we used an Arduino Mini Pro and connected that with a Bluetooth transmitter where we were able to send the data directly to the computer via wireless connection. MATLAB and Simulink were then used on the computer in our programming and control algorithms due to our familiarity and ease of access to them.
While using our Gantt chart, the spring semester began with us finalizing the CAD design and manufacturing the prototype of the pedal. We were able to accomplish our goals up until the second week of March. Many of our components were still in transit and the assembling cannot be physically completed with all the components we wanted. We will be making more theoretical contributions to our project.
If the Arduino boards in our current possession are still working, then the load cell will be connected to the Arduino board in order to find the possible changes of force. Theoretical MATLAB's Simulink will be created to show changes in our force in a graph-like manner rather than VR. This will mostly be a user interface that displays what our final software would have looked like had we had our missing parts. Discussion of future modifications for future generations with the addition of new sensors like a G-Sense.
Thank you.